A semi-cut tailplane was selected over a full cut, primarily for protection. This meant an increased elevator clearance was required along these edges. On reflection, increased reinforcement using tape would be desirable. The servo was located on the underside of the fuselage, with close proximity of the glider's natural centre of gravity, as opposed to being side-mounted to keep the lateral and aerodynamic stability during flight. The negative of this location is that the servo can take damage, however the rod-servo combo is much stronger than polystyrene fuselage. This also allows the rod to act as a structural support and as a skid to protect the fuselage for numerous landings. The trade-off here was between allowing the fuselage to take damage or servo and rod. Two servo supports were installed with a connecting rod to act as an actuator system as opposed to one, allowing a more equal force to be applied to the tailplane. Wider supports meant the rod bent instead of deflecting, hence why they are slightly more central. Moving the servo closer to avoid this bending would have caused the centre of gravity to move back, leading to increased instability. In hindsight, we could add more supports to prevent elevator bending, as well as ensuring the elevator is cut more precisely to give increased equal deflection. Measure twice, cut once. The first test was with the elevator at -30 degrees deflection. We then tested a range of other elevator positions from neutral to max up, deflecting at 50 degrees until we found the aircraft was trimmed with a deflection at +5 degrees. For the condition of trim to be satisfied, the aircraft must be longitudinally trimmed with all clockwise moments equal to the anti-clockwise moments, and thus creating a zero pitching moment about the aircraft's centre of gravity. When the elevator was deflected at any other position other than 5 degrees, it led to an imbalance of moments about the centre of gravity, resulting in either diving or a climbing then dive motion. By measuring the distance flown and the time of flight, we were also able to calculate glide ratio. From this graph, it can be seen that deviating from an elevator angle of 5 degrees greatly reduces the glide ratio. First we tested an aft centre of gravity position, then mid and finally forward. It can be seen that moving the CG forward up to a limit increases the glider's stability. Moving the CG aft meant trimmed flight was unobtainable as the pitching moment about the CG were imbalanced.